today we're going to continue completing the second model of the SAT test 7, right? We're going to start from where we left off last time, which was question number 21, right? We're going to start going over to question number 21. Today we're having some questions basically all over. Several geometry questions, several just basic algebra questions. I would like to talk over in depth over every single question here, since these questions are already from basically from the harder part. This is a 2-star questions and 3-star questions. So as we agreed before that we are going to do the logic part of our SAT prep here, then we just should take our time and go over every single question in depth. And before we start, I hope everyone is enjoying their break. I hope everyone can can put a little bit extra of your mind towards understanding these problems right now. Having said that, we are taking off right now. Okay. So let's start by doing question number 21. I think I'm going to copy and I'm going to open this question on my Paint feature, Paint program. Why? Because I think this is a clear geometry question. So I'm going to read it in a second. And I think geometry questions, well, most of the time they require us drawing just even for ourselves' sake to be able to solve it. So let's see. Let's see what we are going to have here. Okay, so a line intersects 2 parallel lines forming 4 acute angles and 4 obtuse angles. Okay. The measure, so far everything's super clear. Okay, the measure of one of the acute angles is this expression. The sum of the measures of one acute angle and 3 obtuse angles is this expression. What is the value of W? Okay, so in order to find a variable, right, we often need to create an equation. There has to be an equation created. So once we can create an equation, we'll be able to equal one side towards the other, and we'll find what we're looking for. So let's see how it's gonna go. Well, you know what? Maybe I should have not used this. Is just do it here. Kind of try to draw it on the paper as you would probably have to. So let's see if we can find a space where we can do it, assuming that here you're gonna have everything written. So yeah, we're gonna do it here. So 2 parallel lines are being intersected by another line. It's also called transversal, and it does create 4 acute and 4 obtuse angles, basically like these on the other sides. Now let's just put it in as what we see. So acute angle, so this angle is 9x minus 560, and okay, so interestingly enough, we can represent the other side, the other angle. The obtuse angle can be represented through the acute angle. And then most likely we're going to have a sum after. So how can we represent the obtuse angle? So we have acute, right? Which is 9x minus 560, and we have obtuse. That's technically a supplementary angle with the acute one, right? two angles that stand on the same line, right, are called supplementary angles. So they do add up to 180 degrees. Both of them add up to 180. If we know one and don't know the other, we can re-represent the other one by subtracting the one that we do know from the 180. So what we're going to have is we're going to apply the minus on both of the things of the parentheses, because we're subtracting both of these things. And it's going to be 180 minus 9x plus 560. You have to be very precise over here. Like one wrong move and the equation will be wrong, and then everything will be wrong. So what's going to happen is that 180 and 560 are going to add up into 600 and 140, 740. So it's going to be negative 9x plus 640. And thus we just created a representation of the obtuse, one of the obtuse angles. It's going to be here. And now they say the sum of the measure of one acute. So we take one acute. I wish I could actually have more space now because this is not over. We haven't even set up an equation. So I'm going to set it up higher in terms of what you're going to do on a test. I don't know. Probably you should have some like a scrap paper to do it real quick, not to break your focus at the same time. So one acute angle, so acute is what was given to us originally, so 9x minus 560 plus, because it says sum, right? So we have to add things, so plus 3 obtuse angles, so 3 times the obtuse angle representation, minus 9x plus 740 equals to this. And okay, I'm going to share my thoughts in a second. So let's start by just combining all the like terms, distributing, so all of that. So it's going to be 9x and minus 560, we keep that. We distribute the 3 onto negative 9x. And yeah, this is, what is it? 2100 and 120, 2220. So plus this, I hope I'm not mistaken there, equals to this. And guys, there's no way around it. There's no way to do it in any way faster. This is it. This is what you have to do, unfortunately. And I see my mistake already. I distributed, my bad. I distributed 3 onto 9. I was speaking at the same time. So it's, yes, it's this. It's negative 27. Obviously, 3 times 9 is negative 27. And we combine like terms. 9x and negative 27x will be negative 18x. And, okay, why do I keep wasting our time? Because clearly we can do some of these calculations on the calculator. So 560, we make it negative, and we add 2 to 0. We get this, so plus this equals to negative 18x plus w. And guys, the fact that it's negative 18x and negative 18x on both sides is not an accident, because otherwise there is no way we can find w. In one linear equation, it's impossible to find two variables. Like we have x is one variable and we have w, there's another variable. So there is no way in one equation we can find the value of two variables. Two variables we can find only by having a system when you have x and y. 3 variables, you need triple systems, but that's from Algebra 2 pre-calculus stuff, so you won't see that here. So naturally, when you do this, it should feel like, hey, how in the world the x is going to eliminate, like, so I can have a w? But it's kind of like you have to, like, at this point, you have to believe that it's going to factor, that it's not going to factor, but it's going to somehow cancel out, which it does over here. And now we can clearly just say 60 and 60 equals to w, and that's it. That's the answer. That's the answer. I can confirm that this is the answer because, as you guys know, I don't pre-solve these questions, but let's see if it's true. Oops. I'm checking right now. Okay. This is question number 21. Yes, that's correct. 1660 is the answer. So now let's have a short discussion on like how long will it take us. First of all, this question is gives me a weird vibes in terms of that you can't really let it go because it's because the concept is relatively easy here. Like you can't just say it's too long, I'm not gonna do it, I'd rather save some time and I don't know, come back if I have extra time to solve this. You can't, because it's a definitely solvable question. But at the same time, it takes you so long, you know, like first you have to figure out how to set up the second angle and then do the sum, equal it to something, and then start solving. And this you cannot avoid. Plus, you have to be really focused because, like, I noticed my mistake, right? That I didn't multiply 3 times 9. But who knows if I wouldn't? Then I would be stuck. Then I would have to go back, look for my mistake, find it, and go back and solve it. So it's I don't know. So yes, it's doable, but at the same time, it's a complete time waster. But a good time waster. At least you know that you most likely will get that right. Okay, so we have to move on. We can spend more time on this. This is broken down, I hope very clear. I can put on the chat on over here so I can see it. And if you have any questions, you can direct message me over the chat. Okay. All right, we're moving on, and we're moving on into something that looks like this: a table. I don't know. A table always warms my heart a little bit. Why? Because well, what they can really ask me that we don't know here, you know, it was a table. Like, when we have so many points, there's so many things we can do, you know, slopes, equations of the line, you know, stuff like that. So it's hard to be scared, you know, when you look at this question. So you have to go into a question like this being very, very confident. All right. So for the linear function f, the table shows 3 values of x, and they are corresponding values of fx. What does it say from here to here? Nothing. They just say, hey, this is the function fx here. So it means nothing, pretty much. We see that on our own. If h of x, now there is another function, h. equals to function fx minus 13, which is means basically just function f lifted down, which equation defines h. So if we're gonna find the equation of the function f and shift it down, this is it. That's gonna be it. Do we know how to find equations from we know how to find it from 2 points. This is more than 2 points. This is 3 points. So we can definitely do that. And what's interesting, what can save you some time is that when a line is being shifted, like let's say if you have x and y plane, right, and there's a real line, no matter how high and how low we shift it either up or down, the slope of the line won't change. What does that mean? It means that the step 1 of this problem can be skipped. You can cut that step. Let me tell you how it works if we don't know the slope. When we don't know the slope, step 1 into find in the linear equation in y equals mx plus b form is to find slope, right? To find slope. And obviously you're gonna have to do this, and well, you don't have to do this here, but I'm just showing you how this problem becomes twice as long. And then you have to like mark this as x1 y1 x2 y2, right? And it's a fraction here, so it's not going to be a picnic there, right? So and then the step 2, so this is step 1. Step 2 will be find the y-intercept, is to find that location, find b. It's called b actually, the y-intercept. And then we're gonna basically, when we find it, then we're basically gonna shift it down. But just like I said just now, that the slope of the line, no matter where we like, how do we shift it, up and down, left or right, the slope won't change. So that means that this step can be skipped because the line h will have the same slope, and it's everywhere 5. So this can be fully skipped. But what do we do then? What's interesting is that then we use the same slope in, this is already like a technical thing to do, because in order to find b, we have to take 1 point, x and y. We can use -4 and 0, which is actually not that hard to use. 0 equals 5 times -4 plus b. 0 equals -20 plus b. Add 20, add 20. So it's 20 equals to b. And this is not the answer, but this is the y-intercept of the fx. So the equation of fx would be, let me put it in a different color, y equals 5x plus 20, which we're gonna have to lift down. So basically all we have to do, as easy as it is just subtract 13 from that 20. This is it. This is it. 5x plus 7, right? 20 minus 13 is 7. And b. This is b. So, the recap. Understanding that what we need. So first of all, first feelings is that I can do anything if I have a table. I can create, and even if I didn't have those slopes, I would be able to just do that first step, which was finding slope, and then do the second step to find the b. I could do that. It just would take me, I would say, twice as long, but I would get there no matter what. All right. Moving on. Moving on. The linear function g. So we're almost getting into the hard question. So 23 is officially, I think, is still should be relatively doable. But 24, 25, 26, 27 is the last four questions that should be technically harder. So we'll see. We'll see. Okay, so the linear function g is defined by, okay, again, a linear function. That was a linear function. This is a linear function. So there's a function g, and it's b minus 15x, where b is a constant. What this means, a lot of people actually get confused what this means. This means just where b is a number. Where b is a number. 5, 6, -3, I don't know. It can be any number. So, and there is a function. So if g of, okay, so if this what happens to g equals to c over 4, where c is a constant, where which of the following expressions represent the value of b? Relatively easy question if you have ever done just general algebra. Because what we do when they show us a function, right, and then they show function and let's say a regular number, we just plug it in that number instead of the x. But here we don't have a number. We have an expression, c plus 7. What do I do here? Same thing. I plug it in inside of the x into that function, and let's see what happens. It's going to be b minus 15 times, because it's x, times 7 plus c plus 7. And this plugin will equal to c over 4. And this plugin equals to c over 4. That's it. All we have to do now is just to solve for b. But this is already, and this doesn't look actually that hard. So let's see. Actually, no, it's not hard. So negative 15c minus 70 to the 105 equals to c over 4. Now we're going to, let's deal with c's first and just add it to the, get rid of it here and add it to this side. And I'm already writing 15c a little bit higher, so I can put over 1. Because it's a fraction, I'm going to have to deal with this fraction. I'm going to have to add it somehow. So this goes away, and we get b minus 105 equals 2. And now I have to add here. Do I have to worry? No, because all I have to do is just bring them to common denominators. And it's easy just to make this into a 4, right? This denominator into a 4 by multiplying. So it's c over 4 plus 60c over 4. And c over 4 plus 60c over 4 is 61c over 4. So that's gonna be here. 61c over 4. Now I'm gonna split it like this. And the last step is to add 105. So plus, like, you shouldn't even be worried about this. This is very basic. It's not basic, but it's like, it's very like kind of like, it's hard to not see it. It's 61c over 4 plus 105. There we go. All right. I don't even know what comments can I make. This is, you have to remember how to do it. You have to remember that this type of question exists. You need to know how to do it. It's not hard. And do it when it comes in and be like, hey, you know, like number 23. It's already number 23 and this question came up, which is easy. All right. We're at the question 24. We're getting into Twilight Zone. Let's go. Let's get in. In a triangle XYZ, angle Z is a right angle. Okay, I'm I'm kind of like I'm not even reading further before drawing because I want to see. Okay, I want to see how it looks like. So Z is a right angle. So Z and maybe it's gonna start with X on top, X, Y, and Z here, and Z is a right angle. And the length of YZ is 24 units. All right. If tangent X, okay, equals to 12 over 35, all right, what is the perimeter in units of, okay, so we have to find the perimeter, so we have to find two other sides. By having a tangent value and by having one of the sides is already enough. Because first of all, we have to look at which angle is being used here, angle X. So we mark. I would always mark the angle X, and say that opposite. So tangent, right, from trig or from geometry even, tangent equals opposite side over adjacent side. Opposite side is 24. The adjacent side is this side ZX. Okay, and in order to get the side Z, so we have to, since the tangent, so hold on, since the tangent equals to 12 over 35, but in reality it's not. So the opposite side in our case it's 24. In our case, this side is 24, but in the representation tangent, it's 12. What does that mean? It means that if we make this into 24, which by actually just multiplying by 2, we would have to multiply the bottom by 2 and get the adjacent side. So it would be, technically, it would be tangent equals 24 over 70. And now it matches our side, and now my adjacent side, I know, will be 70. That's how it works. Now, we could have set up a proportion, but I'm showing you exactly like why and like exactly like the details how it actually happened. So now, since we know two sides, we can find the third one by using Pythagorean theorem. 24 squared plus 70 squared equals c squared. And from there, it's a calculator thing. 576 plus 70 squared is 4900 equals c squared. Now we're gonna do 576 plus 4900. It's that number, and I don't even write this number down usually. I just press my square root right over here. 74. 74 will be our hypotenuse, and now don't forget that we're looking for the perimeter, so we need to add all of the other sides, and I'm still not even writing it down because I know what to do. Why would I need to waste my time to write it down? I know that I have to add all the sides. So right here I write plus 70 plus 24, and boom, this is my answer. I know I got it right. I'm not even worried that inside like that it could have been wrong. Technically, without explaining it, this should be an under a minute question. Okay, a minute, exactly, maybe a minute. So there is still my point is that you still saving time on this question. This is not where you have to spend more than it that's given to you per question. This is saving time question. Okay, we're moving on into question number 25. All right. Again, this is already question number 25, but I'm seeing what I'm seeing. I'm seeing a circle question. And just like in linear equation questions, circle question is just not that much there to ask to make you get even a little bit of stumbled. So let's see. Let's see what's happening here. Okay, sorry. In the xy plane, the graph of the given equation is a circle. What is okay? So thank you very much. We knew that. What is the length of the? So just find the radius. Okay, so guys, whoever doesn't know that part of the theory, please pay attention now because this is just knowing how to do it. That's it. It's not thinking here. This should take you about 20 seconds. I don't know, something like this. If the numbers are not hard, if the numbers are hard, 30 seconds. So let's go. Circle question. I have to make sure that x's stand first, run after another, that y's are after it, and right away I see that one of the y's is on the other side, so I have to bring it back, and I'm writing it as I'm bringing it back. So it's minus 6y equals to 109. What do I do now? Now I do something that's called completing square method, but in reality I actually showed before like a shortcut. You create two parentheses squared, and inside of those parentheses you put half x and half of the number that's the b value, so plus 7. Over here you put y and you put half of the number there, so plus 3. And what you need to remember is that those numbers must be, or actually their squared versions must be added to the right side. So it's going to be 7 squared and negative 3 squared be added to the right side. This is it's just a memorization. You need to remember. Don't try to understand, oh, why do we have to do it? No, just remember the way. Because if they ask you about coordinates of the center of the circle, right, then it's those two numbers with opposite signs, like negative 7, 3. But the radius part is on this side. This is radius. This is radius squared, actually. So 109 plus 49, because 7 squared is 49, plus 9 equals to 109 plus 49 plus 9, 167. But since it's radius squared, then what do? We square root it and leave it, because that's already the answer. Guys, this if you remember that all of the videos and all the classes that we have here, I'm streaming into my YouTube channel, Gotham Math, so you can like always rewatch this if you like want to refresh your memory on questions like this. Okay, and from here we're moving on. Also, on a confident kind of note. All right, now now number 26. So the last two questions, guys, it's two important questions. So I hope that your math grades, right, your math score is going to happen here on the last two questions. That's where it's gonna matter. Because I hope that up until this question, you would go as confident as you could, pushing, pushing, pushing. And don't forget, these two questions are the last questions of the test. Because the first part is the ELA part. Then you did the model 1 of the math. This is model 1, model 2 of the math. And these are two. So this is going to be two last questions of your test. So obviously, you're going to be a little tired, but hopefully still tired, but still having energy to finish it strong. So let's see how hard they are. So the speed of a vehicle is increasing at the rate of 7.3 meters per second squared. Meters per second squared. Interesting. Why? Okay, so what is the rate in miles per minute squared? Okay, rounded to the nearest tenth. Okay. 7.3 meters in 1 second squared. Interesting. So 1 second, right? Yeah. And we need to convert this into miles. 7.3 meters is a small number. So, and they gave us actually the conversion rate. So can we convert these meters into miles right now, right here? I think we can. Setting up a proportion, saying 1 mile is this many meters. How many miles is 7.3 meters? And from here, I do multiply across and divide by the number that's outside. So it's going to be 7.3 times 1. So 7.3 divided by this number. Let's see what it's going to be. 7.3 divided by 1609. That number, 0.005, let's say, in 1 second squared, right? I'm sorry, yeah, second squared. So now it has to be per minute, right? And interestingly enough, I think we just have to convert this. So basically, in order to keep this as a 1 minute, I have to multiply both sides by, well, 1 minute squared. It's kind of like minute times a minute, right? Which is 60 seconds times 60 seconds, which is 3,600 seconds. So if I multiply both sides, this will still can stay one. No, if I multiply the other one, this can stay as 1 minute, I guess. And this can be multiplied by 3,600. Let's see if it's right. I don't know. It's actually... Oh, I should have just left it there. Okay, so times 3,600. 18. Hold on, let's do that number. Let me not actually like round it. 7.3 divided by 1609 times 3,600. Oh, okay. So 16.3. Now, is that a right answer? Well, I can check, because the problem is actually something that we haven't seen a lot on SAT questions, especially on. So choice B is correct, guys. That is someone's mic is not muted, so I can hear the background noise. Guys, check it, please. All right, so. So let's recap this. Let's recap this calculations and everything. Is the question easy? Yes, it is. But is the question weird? 100%. 100% weird. 100%. What the hell? Second squared, minute squared, why? Right? Per second. What's this is this is something that I think you should just go with the feeling, because the idea is to convert miles and then multiply it by 3,600 because it says minute squared. But what if you don't get the idea that minute squared is 1 minute times 1 minute, right? Which is 60 seconds times 60 seconds, which is 3,600 seconds that we have to convert this by. So, whew. So yeah, weird, but this is something that I think is doable. Maybe if you wouldn't go that way, but go another way, like let's say, and then didn't get anything, just do a minute and a second, and then go back and try again and try with a minute squared. I think that you would get that right. Okay, so we have actually exactly enough time to do another question, the last question. And as soon as I glimpse at that question, I see that this is a classic. How it is at question 27, I don't know. Usually this question is around 23, 22. In this case, I think that after that weird question, they decided to just do and put something clear, something that we have done before, something that we have prepared from previous tests. So let's see. A system, and it says in a given system of equations, k is a positive integer constant. The system has no real solutions, and that's what we want to know. No real solutions. What is the least possible value of, okay, least possible, so maybe there will be I don't know, should not be any problem there. How does that work? First of all, it's a system, and we have to do plugging in. So let's plug in this and substitute that y with it, right? Just like we do on any substitution problem. But again, you know what? This problem, at the point where you have been, like, let's say, taking my classes for a while, we've done, guys, how many questions we have done? Daniel, sorry, I just saw a message. Yes, it is Gotham Math. Yeah, it is. Oh, someone asked. Okay, yeah, Gotham Math. Thank you, Daniel. Thank you. I didn't see it. Okay, so x squared plus it. So what I was saying is that if you've been taking my classes for like some time, you have seen this question before. Like exactly, almost exactly the same. It's just different numbers. So what do? We have to equal it to 0, kind of by moving the 2.5 to the right side, right? Moving it there and putting it next to k, because technically it's k is a constant, so it means that k is a regular number, right? And plus k plus 2.5 equals 0. Now, when does the function have, again, theory, when does the function have no real solution? It doesn't have any solutions when b squared minus 4ac is less than 0, or in other words, negative. Negative, remember, a negative answer is no solutions, 0 solutions. Positive answer is 2 solutions, and 0 If the answer is 0, one solution. So that is a theory that you need to know. Now let's do b squared minus 4ac. All right, so b squared, 8 squared minus 4 times 1 times, and then the c. And the c is this, k plus 2.5. It has to be less than 0. Okay, let's solve it. 8 squared, 64. Negative 4 times 1 is still negative 4. I don't know. Okay, I'll write it down. Even though I wouldn't in real life, like on the real test, but I don't want to skip a step. I know this one is kind of like still there. So minus 4k and minus 10 less than 0. Now 64 minus 10 is 34, minus 4k less than 0. Subtracting 34, we get negative 4k less than negative 34. Divide by negative 4, we get k. Actually, it has to be greater than, right? Because when we divide by a negative, the inequality sign flips. What is it? 34 divided by 4. Oh, no, wrong numbers. 34 divided by 4. 8. Guys, I'm seeing a thing where yeah, I see a small calculation mistake. Oof, I wouldn't want to make it on the test, guys. I kind of, maybe I wrote it wrong. Okay. Yeah, so it's as, I don't know, maybe the way I wrote this I don't know. 64 minus 10 is 54, not 34. Minus 4k less than 0. You know what? Being tired could do it to you. You know, I'm not saying I'm tired. I'm just saying if this is the last question of the whole SAT test, right? Okay, greater than 54 divided by 4 is 13.5. So what is the greatest integer? I mean, what is the smallest integer? But k has to be greater than 13 and a half. The answer is 14. 14 is the smallest possible. And I just checked, that's the right answer. That's the right answer, 14. Look, I don't know. I would probably be more focused. You know, I would not want to make a mistake here. This question is mostly theory, right? This question is not even theory, but knowing how to do it. No, actually, this is not a theory. It's somewhat theory question, but this is experience type of question. You have done it before, you know how to do it. If you have done it before, you know how to do this. And, well, luckily, that's what we do. So, quick recap of the whole thing, of what we did today. Everything here was very doable. I don't see a single question that was undoable. This, like this question kind of checks your belief, you know, in yourself. And everything was easy until question 26, which was easy but weird. Very, very weird, but easy. Well, I wouldn't be sure. Even if I got it right, I wouldn't be sure that I got that question right. You know, this question would leave a mark on me of being like, I may have not gotten that right, but everything else would. Everything else would. You know what? And if I would get this question number 26 wrong, so be it. So be it. You know, one wrong on a second model, last one. So listen, excuse me. And it's a multiple choice. You know what I mean? You could have gotten that right anyways. Like you could have like just gotten it and gotten right by uh, even like guessing it a little bit. You know what I mean? All right. This is it. This is it for today. Uh, on Sunday, guys. One more thing. On Sunday, I will give you something to do as a test. Remember, like on over the live classes, we're going to do a lot of like test taking skills, right? Taking tests and then discussing uh, like where you could have saved some time and such. But mostly it's going to be that. And I want you, before you leave right now, I want you to, because remember I collected your phone numbers. I want you to direct message me uh, the platform that you would be more comfortable with taking, like us having a group chat, and the most popular one will win, and everyone will have to do that one. Like, you know, if it's, I don't know, I don't know, iMessages, or if it's a WhatsApp, or anything that you use uh, would would work. But again, guys, whatever wins. You know, then we're gonna have to follow the majority. Okay, this is it for today. Please direct message me the messenger that you would be comfortable with using, and that will be it for today. I'll see you on Sunday.
All right. Have a great night.
Bye, Daniel. Good night.